Hello, Mr. Betts here. Now that we have shortcuts for taking the derivative of the sine and the cosine function, and now that we know the quotient rule, we can use those two things together to take derivatives of the other four basic trig functions. So we can take derivatives of tangent, cotangent, secant, and cosecant using the stuff that we've already learned. So I'm going to do a couple of these as exercises here. The other ones you can confirm on your own. So let's start with the tangent function. I do want to point out I'm using theta. That kind of implies that we're taking the tangent of some angle. Usually we use Greek letters for angles, but this would work whether that's a tangent of x and taking the derivative with respect to x or really any variable. So the first thing I'm going to do is I'm going to use a trig identity that says tangent is the same thing as sine divided by cosine. So I'm going to rewrite this problem as the derivative with respect to theta of sine of theta divided by cosine of theta. Now, by writing it like that, we have sine and cosine involved in this expression. We know how to take the derivatives of sine and cosine, and since they're part of a quotient, it's sine divided by cosine, we're going to use the quotient rule. So this derivative, we're going to use the quotient rule. So I'm going to use that rhyme, low d high minus high d low over the square of what's below. So low is cosine, that's the bottom function. D high, so derivative of the top, the derivative of sine is also the cosine function, minus high, which is the sine function. D low, so the derivative of cosine is the opposite of sine, and then all over the square of what's below. So over the square of cosine, which is cosine squared of theta. Now, this is technically the derivative of tangent, but we can simplify this. We can make this expression look a lot cleaner. Oops. So I'm going to do some simplifying here. The cosine times cosine, I'm going to write as cosine squared of theta. And then we have plus, because it's negative times negative, sine squared of theta, and then all of that over cosine squared of theta. Now, we could write this as we could divide cosine squared by cosine squared and get 1, and do sine squared over cosine squared and get tangent squared of theta. But I'm going to simplify this even more using the Pythagorean identity. Remember, sine squared plus cosine squared is 1. So using the Pythagorean identity, we're going to get 1 over cosine squared of theta. And remember, 1 over cosine of theta is secant of theta. So we can rewrite this as secant squared of theta. So the derivative of the tangent function is going to be secant squared theta. If we do the same thing with the secant function, so the first thing I'm going to do is I'm going to rewrite it in terms of trig functions that I know derivatives of. So we can write this as the derivative with respect to theta of 1 over cosine of theta. Now we can do the quotient rule on this. So low is going to be cosine of theta. D high, the derivative of 1, remember the derivative of a constant is 0, so that's just going to be 0, minus high, which is 1. D low, derivative of cosine is the opposite of sine, over the square of what's below. So simplifying this, we're going to get, let me use a different color here, we're going to get sine of theta over cosine squared of theta, which I'm going to write as cosine times cosine. So generally the way we're going to see this simplified is we're going to see it written as two different trig functions. We're going to see it as sine of theta over cosine of theta, which is tangent. I'll stick with the same color. So the tangent is from the sine over cosine, and then the cosine, 1 over cosine is going to be secant. And I'm going to switch the order just because this is the order that we generally see it. So it's going to be secant of theta times the tangent of theta. It really doesn't matter if we have the secant first or the tangent first, but this is usually the way that we see it in textbooks. So again, the 1 over cosine of theta became the secant of theta, and the sine of theta over cosine of theta became the tangent of theta. So the derivative of the secant function is going to be secant times tangent. And keep in mind that when we're taking the derivative of a function with theta in it with respect to theta, we're going to get a derivative with thetas in it. So this is a list of all of the derivatives of all 6 basic trig functions. And so the 2 of them up here at the top we knew already. And then the rest of them we can get by using the quotient rule and some trig identities that we should know from pre-calculus. These are all derivatives that I do expect you to know, so you need to memorize them. They are all derivatives that if you do forget them, you can always derive them just like I just did. But it is a good idea to memorize these because they're going to be derivatives we're going to use a lot, and the better you know them, the quicker it's going to go. And by the time you take the AP test, I want it to be second nature. You know that you know all these derivatives and you know them quickly. I want to point out a couple of patterns here. So on the left side we have sine, tangent, and secant. And on the right side, we have cosine, cotangent, and cosecant. So these are all the cofunctions over here on the right side. And if you look at the derivatives of all the cofunctions, they're all negative. All right, so one thing to keep in mind is if you're taking the derivative of any cofunction, it's going to be negative something. The other pattern that's going to be really useful is that if we take the derivative of the non-cofunction, so sine, tangent, and secant, to get the derivative of the cofunction, it's basically going to be the opposite. So it's going to be the cofunction for that function. So the cofunction for cosine is sine. The cofunction for secant is cosecant. So instead of secant squared, we have cosecant squared. And obviously it's negative cosecant squared. Instead of secant times tangent, we have negative cosecant times cotangent. So these are the cofunctions for these. So just a couple of things that can help you. Those patterns might help you remember them, but you do need to have these memorized by the time we start taking assessments later in class.